the few, the brave, the Friday morning 9 o'clock attendees. Thank you. All right. My name is Pierre, and I'm a VM. And with me I have...
Hi, folks. I'm Vinicius, and I'm a container. And to really show that Pierre is a VM, he has a yellow notepad with notes for the session.
I am not just a VM, but I'm an old VM. I haven't been rebooted in a long time. Anyway, so this session is kind of like a part 2 of last year's, where we did something very similar on how skills for an IT pro, a system admin that mostly runs in traditional data centers and traditional workloads, that those skills transfer very, very well to the new cloud native, like the new shiny, or what did Justin, oh yeah, the new frontier company. Today we're kind of like going a little bit further and kind of driving a bit more into what the differences are for all of the portion of what you need to run in your infrastructure when you're supporting cloud native Kubernetes and containers versus VMs and scale sets. So in this session, we'll assume that you can spell AKS and that you've got maybe just a tiny little bit of knowledge of what it is. That you've seen some demos, because if you've been at Ignite, you've probably seen AKS in every other session. That you maybe have tried to load it, and maybe about halfway through when it failed 3 times, said, "What the hell is this?" and then walked away. But also, in this session, there will not be any dev tool content. And after a week, you're probably going to be happy that we will not talk about AI. Thank you. All right, but when you get lost, complex things are brought in. So that's where I wanted to get Vinny to start talking about Kubernetes and when you use it.
Thanks, Pierre. All right, so I'm not going to read through the agenda. The thing about this session is we have 2 points of view when we get into Kubernetes, right? There are things that change, like we changed how we deploy things. So Kubernetes is going to change how you work with the deployment process for your application. And we're going to show a few things that will help you understand why we are changing that. And then we're going to get into another part of the session where we show that things didn't change much. So monitoring is still monitor, DNS is still DNS, networking is still that, right? Networking is still networking. Governance is still governance. It changes how you apply this to a Kubernetes environment, and we're going to show that in Azure we have a few tools to help you with that. But your role as an IT pro and an operations person didn't change, so we're going to show you the tooling for working with Kubernetes. Now, one of the main things that we want to convey in this session is the technical aspect of deploying to Kubernetes. But one of the things that we hope you understand getting into the session is when to use Kubernetes or when not to use Kubernetes, right?
But how many of you think that bringing Kubernetes into your environment just adds complexity?
Yeah.
Okay, so about a third of the room. All right.
And you might be right. If you don't have the scenario to actually run Kubernetes, if running Kubernetes is going to be more complex than running your app, then you should not be doing Kubernetes, right? But there are a lot of scenarios where Kubernetes brings a lot of advantages. And that's why we are bringing this slide about the DevOps practices, because at the end of the day, the developers, they want to work on the development cycle of the application. They don't want to be dealing with the infrastructure in the production environment. And that's where you as an IT pro come in, and that's what we're going to talk about in the session today. One of the things to keep in mind as we go through the session is we are going to show some of the tooling inside of Azure for managing a Kubernetes environment. However, AKS, or Azure Kubernetes Service, is part of a larger cloud-native ecosystem where you could be replacing some of the components that we are going to talk about.
We're not covering all of these, are we?
Oh yeah, one by one. Yeah. No, just kidding. The point of this slide is, if you're thinking about monitoring, there are multiple options for monitoring your environment. We're going to show one of those. And we're going to show, for example, for monitoring and governance, the tools in Azure that will help you do that. But as you think about Kubernetes as a whole, even outside of Azure, you should be thinking about what is the right tool for the right scenario that I have. And that's where the cloud-native ecosystem comes in, and you have multiple options to choose from. All right, so the first thing I want to cover is environment variables and secrets. And the reason why we do this and why this is important is I talked about the scenarios that you should be using Kubernetes and the ones that you should not be using. One of the things that we understand is a given when we use Kubernetes is that you can reproduce the deployment process that you have between a testing environment, between a quality environment, and the production environment. In the old days, when we used to deploy VMs, you would hard code configuration for that application into the code of the application or into the system that supports the application. So how many of you have deployed IIS in the past? All right, so you know that you can configure the connection string for the database into IIS, so the application looks at that and talks to the database, right? Well, if you are deploying the same application in a testing, in a quality, in a production environment, one of the things you want to do is you don't want to hard code that configuration into the app so you can reproduce that deployment over and over.
What? I can't put my password and my connection strings in my documentation and it doesn't work anymore?
No,
Okay.
It never worked, but anyway. Well, let's go. So let me show you what it actually looks like in a demo. So the first thing I'm going to do is I'm going to show you the sample application that we're going to present today. That's very quick, just to show what the application looks like. We have a admin site and a front page. So the customers of my company go to this website. They can come here. They can look at the products that I have. They can add to the cart. They can say, I want more than one. I'm going to check out. I bought my product, and I can continue to shop. As an employee of my company, I can come here, and I can go to the admin page and manage the products for my website. I can add a new product, and one of the things that I'm going to take Pierre's comment is that we are actually going to show AI without showing AI. So we have an option to generate the description of the product right here.
We weren't
right?
supposed to cover that.
I know. I'm a container. I'm cooler. All right. So the thing is, to get to that AI service, I need a few things. I need the HTTP endpoint. I need the key, which is essentially the password to talk to that endpoint. And I need to know which deployment for the LLM that is in the background that I want to talk to. I'm not going to get into the details of that. The point is, I have secrets that I need to provide to the app in order for that app to talk to the endpoint, right? So looking at the resources inside of Azure for the application, we have multiple stuff here. We have a Kubernetes cluster. We have a managed identity. If I keep scrolling here, I have Azure Key Vault. I have a Cosmos DB database. I have a service bus because when customers check out, there's a process in the background that checks for the orders and updates the database. I have the OpenAI service, and I have the registry where my container images are stored, right?
But if I was running this in a VM, all of this stuff would still be there.
Pretty much, but you don't get the flexibility of the process, like the reproduction of that in another environment with the reconfiguration of all the things that I'm just going to show now.
Got it.
So I'm going to open Visual Studio Code, and I know this is a IT-focused audience. The point of showing this is the code of the application. I'm an IT pro. I don't actually do coding, but the one thing that I want to show in the application is that the developer that worked on this application, he actually, instead of hard coding the information inside of the app, he said, I'm going to use a variable for that information that I just talked about, the endpoint, the password, the key, and the deployment that I'm going to use to talk to the OpenAI service. And I'm going to mount those inside of the application using a volume mount. So this will be information inside of the pod, inside of the container that runs my application. So the things that I said that I need, the key, the endpoint, and the deployment.
So wait a minute. You're mounting a variable?
Yep.
It went in
just like a file.
just like a file, just like a folder.
Yep.
So doesn't that get confusing?
Why?
Because I'm a VM, when I mount something, I mount a storage.
Yep. A container, from a compute standpoint, is just like a VM. Hopefully, at this point, you understand that the virtualization process for the container is very similar for the VM, but instead of virtualizing the hardware, we're virtualizing the operating system. Well, guess what? It's an operating system that see a volume mount, you see files, it operates pretty much like a VM. You manage it in a different way.
Okay.
All right, so moving on, what I'm going to show you now is the deployment YAML specification. Hopefully you understand what a YAML specification is. This is the deployment of my admin site. So you see that I was showing you the page for adding a product. It's expecting those variables. And what I'm doing here inside of the process of deploying the application, I have the image that deploys, I have the port that I'm going to deploy, how much CPU and memory I'm going to give to this container, and then we get to the variables. So the volume mounts that we just talked about are right here. So the key for OpenAI, the OpenAI service, and the deployment. And those will be mounted as a volume mount. And the thing about Kubernetes is that, remember that I said you have a lot of flexibility with cloud native? One of the things that we have is we have what we call CSI, or the storage interface. I forgot what the C is, but the storage interface is also something that you can pick and choose between multiple options in the cloud native environment. The one that we're using here is one that talks directly to Azure Key Vault. So the secret from Azure Key Vault is going to be mounted as a file inside of the container. And the way to talk to that is by using what we call as a secret store. So the secret store here is bringing a lot of stuff like the Cosmos DB database, the service bus, and the OpenAI. Now, this comes from another file that I'm going to open here just to show that if you look at the Azure Key Vault, we have the OpenAI deployment name, and there's going to be another one for the HTTP endpoint and for the key. So if I go to my Azure portal, and I look at the Azure Key Vault, and I look at the secrets, I have multiple secrets here, including, for example, the OpenAI endpoint. And if I look at the secret, not exactly something that I can't show, but here it is. It's an HTTP endpoint that I can point my application to. The thing is, when I deploy in a testing environment, I might be using one endpoint. When I deploy in a production environment, I will be using another endpoint. All I have to do is point that deployment to the right secret so the application will know what endpoint to talk to, what database to talk to, and so on. All right? One of the aspects of this, however, is how do I make sure that this secret doesn't leak to anywhere else? So in Azure, the way you do that, and here's the part where we start to show that Kubernetes is just another service that is part of Azure. So how do you give access for an Azure service to talk to another Azure service? Any guesses? Manage identity, right? So what we did here is, if I look at the manage identity that I have, I can see what are the associated resources. And I can see that my cluster is here, as well as the node pool. And if I look at the access inside of the Azure Key Vault, so let me go back. And if I check access, for manage identity, I'm going to select the user-assigned manage identity. And then the one that I'm looking for is the Ignite cluster identity. And notice that this identity has the Key Vault secrets user. Because I assigned the managed identity to the cluster ends up accessing Azure Key Vault with that identity, and the identity has the rights or RBAC to read the secrets from Azure Key Vault. If I get to look inside of the container that has been mounted to that folder that I just showed, and that's how the application finds where to talk to. Does that make sense? All right. The next part is Ingress controllers and networking. Now, how many of you are familiar with this view? All right. I was hoping for more hands up, but essentially this is just to say, when you manage a VM, you essentially give it a virtual network. That virtual network card is connected to a virtual switch, but that virtual switch is connected to a physical switch, and essentially you are giving an IP address and you are putting that VM inside of the network just like any other machine, right? When we go to Kubernetes, it's a little bit more complex because there are multiple ways that you can present networking to the pods, right? And you have the node network, but you also have the pod network. In some cases, you might want to use something that we call overlay. By the way, Cloud Native has a lot of terms that you are familiar with. You just don't know the new version of the term. Like, for example, Pierre would say that he downloads something from the internet. I'm a container, so I say I pull something from the internet. It's exactly the same thing. I'm cooler.
I'm older.
But the point here that we want to make, and hopefully you understand, is you have the node networking that's very similar to what we were used to. You have the pod network that's close to similar of what we used to, but then you have an additional layer on top of that. So you can work with the services inside of Kubernetes. The way this works is every pod gets an IP address. It might be an overlay where the pod gets the same access from the rest of the network, or it might be a virtual network that you are giving virtual IP addresses to the pods. You pick and choose depending on the scenario. But the point is, in Kubernetes, one of the things you want to do is you don't want to point directly to the IP address of the pod. You want to point to a load balancer that is going to check how many pods I have supporting my deployment, and then you can access that from the load balancer.
Which is exactly the same way that traditional IT workloads have been run. You run them on the cluster, you run them on a VM scale set. You never point to the individual instances, you point to the cluster IP.
Correct. However, one of the things about services is it's essentially a port mapping, right? So you have a port, HTTPS or HTTP, and then you can map that to inside of the container from a load balancing standpoint. One of the things that Kubernetes introduces is Ingress controllers. And Ingress controllers are a way for you to direct HTTP and HTTPS traffic using a domain name, right? So let me go ahead now and show something else. So I have another, let me actually go back to my cluster itself. So this one, I'm going to go to the Ignite cluster. And then what I'm going to do is I'm going to look at the services and ingresses. And here, what I have for my environment is I have the storefront load balancer, and I have the admin site load balancer. Notice that they have an external IP address, but what I'm doing here is I'm using an Ingress controller to say every time that I hit storefront.mydomain, I'm going to hit the service in the backend. The service in the backend see what are the pods that they need to send the traffic to, and that's how you get to the application. The same thing for the admin site. So in Kubernetes, everything is a YAML. So if I look at the YAML specification of this, what I have here is I have exactly the rule that you would expect. I have an ingress, and I have a rule saying every time you hit storefront, go to this service called storefront in the port 80. Every time you have an admin site .mydomain, go to the service called admin site in the port 80.
And we do this with, again, traditional VM workloads through our CI/CD pipeline. So when we deploy to prod, we kind of fill in that variable. When we deploy to testing or dev, we fill in that variable.
Yep. So when you see here the storefront.vnap ignite2025.com, that's how we get to this website by using the DNS domain name rather than using an IP address. The point here is I can scale up or down the pods in the back end. The service is going to reach them anyway because it knows what are the pods that are part of the service, and the service is being accessed via the Ingress controller. So you can create multiple rules in here depending on your architecture. Now, a few things don't change. So I mentioned that the host network is very similar. Pods have some service provided to them. For example, core DNS. Again, cloud native, multiple options to pick and choose. One of the things that we have in Kubernetes is a DNS service for the nodes and the pods, so you don't have to deal with that. So let me show you real quick what this looks like. So if I go to this cluster, so essentially I'm looking at the cluster configuration here. On the left-hand side, I'm looking at everything that is deployed to this cluster as a configuration. One of the things that I have is core DNS. How many of you in the past have configured a DNS forwarder? Right?
Everybody.
So if you want to make sure that if I go to a domain, I go to the DNS server, I add a forwarder saying everything for this domain, go talk to this DNS server because it might not be publicly available, it might be a private zone or something like that. Well, you can do that. The only thing is that you do this through a YAML file, and this is what the configuration for core DNS looks like. We have documentation saying if you need your AKS cluster to talk to a zone that is only available inside of your company, so no outside DNS server will be able to find it, here's how you have that configuration. So hopefully by this point, you are starting to understand that DNS is always DNS. It's going to behave exactly the same. In Kubernetes, you are going to use what the configuration for your DNS service is. In the case of AKS, we use core DNS. But essentially, DNS is going to keep behaving as DNS has always been.
And when something goes wrong, it's, again, mostly DNS.
Yeah. One final thing. So we have multiple options to choose from when it comes to networking. CNI, or the Container Network Interface, is what we call as kind of add-ons that you can add to your Kubernetes cluster that are going to help you not only establish the network connectivity for your environment, but also apply security policies, right? And again, multiple options to choose from in the cloud-native ecosystem. Some of those are more popular than others. Like, for example, you might have heard about Calico, Cilium, and maybe others. So in the AKS environment, one of the things that I can do is I can look at my AKS cluster. On the left-hand side, I can go to networking, just like any other Azure resource. And one of the things that we have here is the network policy engine. I'm not going to go into too much details of configuring this. I just want to make sure that you understand that the concepts of networking policies that you are familiar with by managing VMs, they apply very similar to networking in Kubernetes. So one of the things I can do here is I can click Manage Kubernetes Network Policy, and I can come here and say Create. I'm going to either apply a YAML file or create a network policy, and here's where all the things that you are familiar with and that domain knowledge that you have about networking comes in. I'm going to give a name. I'm going to say what is the namespace that I want to apply this to, how I'm going to select pods that this applies to, and then you start to add networking policy. So if you've never seen network policies in Kubernetes, still, this should be familiar to you. Pierre would call it inbound and outbound.
Yes.
I call it ingress and egress, right? You see the terms changed, but the domain knowledge of networking is still the same, all right? And I can allow traffic and disable everything else, or I can disable traffic and allow something else. It's firewall as you've been using for your entire career, is just deployed in a slightly different way.
So your your network policies in Kubernetes are kind of like the equivalent of your NSG, so your network security group in a traditional network, virtual network in Azure.
Yep.
So from here to here,
Yeah,
allow, deny.
Yeah, the point of north, south, east, west, that, again, domain knowledge that you have on networking continues to be the same. It's just deployed in a slightly different way. And DNS is still DNS.
Yes.
All right, switch it over to Pierre now.
So that's the part that I am interested in. That's the part that keeps me up at night. That's the part that I, in my job, am more concerned of. I let other people deal with the deployments. I let the other people deal with the application, how it's conceived and put together. I like YAML, like I like a hole in my head. Any language that can be broken with a space should be shot, in my opinion, but that's beside the point. So that's why I like, in my world, monitoring in day 2 ops, and when I mean day 2 is, it's already been deployed. He's already done his stuff. Now I have to come in and manage it ongoing. So what do we really care about? Like, what are those checkboxes that we need to do to send to our management that says that we have done due diligence, that our environment is running properly, and that we've got everything that we need? So we need to maintain or to figure out what our priorities and to run and maintain the service over time. That's basically simplified to say, keep the lights on. If it ain't broke, don't touch it. Maintain it, back it up, make sure it stays up. That is my golden rule. This is why they pay me money, is to make sure that when they come in on Monday morning, that the system is up and running. There's monitoring and performance, so that I know that maybe Vinicius in his config file did not allow enough memory for a specific service or a specific pod. So if I monitor the performance and I see that the memory is always stuck at 99%, then I can send him a note or have this automated to say, hey, change your config file. And then once he changes his config file, because cloud native is so quick and allows dev side to iterate very quickly, he makes the change, and in no time at all, that change propagates through our environment, but I can still monitor to see where it went wrong or where it went well. Maintenance, patching, and upgrades. We all love patching. Patch Tuesday is our favorite day of the month, isn't it? With VMs, we're getting a lot closer to being painless, or as close to painless as we can make it, with Azure patching, and so the no reboots, and like, this is big things in our end. But with containers, like I said, because it's very quick, and this morning we had a problem with that, where he made one change, and all of a sudden, all of the pods restarted in order. There was no downtime. Patching was done. The update was done. So from my end, as a traditional IT pro managing environments that are mostly VMs, we noticed that there was something. I gave him the information. He made the change. It rolled out. I could still monitor it, and everything's still going well. And of course, troubleshooting to meet SLAs, because SLAs are the bane of my existence. So when we look at monitoring, so I'm looking at my VM here, and I've got a few ways of monitor. If I was on-prem, how many of you are still running majority of your systems on-prem? Okay, a fair bit of you. It's hard to see, but yeah. So you're probably using some solution that's on-prem that has, like, maybe it's System Center, maybe you're running Windows Admin Center on all of your machine, or getting the data from the local Windows machine or Linux machines. Or maybe you're using Prometheus or other forms of monitoring to collect that data. But in our environment, even on in Azure, Windows Admin Center still works, and the only reason I'm loading this is to show that what we're getting from a single machine, a single VM in the cloud or on-prem is pretty much the same as what we get when we're looking at native tool. So I get my CPU utilization, memory, Ethernet, disk, info, and of course, because we restarted it, there's not a lot of information here. But if I go to my machine and I go to monitoring, I have my insights, my alerts, my metrics, my diagnostics, my logs, everything based on when you have a VM that comes with it, when you have a series of containers, it's pretty much the same, but you go into Azure Monitor, we have our machines, it's enabled, it's here, but if I go to not monitored, I now have Vinicius's AKS clusters and pods. They are not currently enabled, but for myself, I'm looking at maintaining a proper view of all of my environment, whether or not they're VMs or Kubernetes. I do not have to relearn a new application or a new system. I can, as many mentioned, there's a whole slew of different solutions that are available to you to manage and to have granular view of what's going on inside your Kubernetes, or you can just enable it in Azure Monitor and you get the majority of that information in your log analytics storage space, workspace. And once you have that, then your alerts run the same way, your metric reviews run the same way, your graphing, your historical data, every one of these tasks that we do every day, every month, stays exactly the same. So our skills as traditional IT still apply to our new frontier companies. So we have this, but I also have in my cluster, if I go directly to the cluster, see there's a monitor tab here that gives me the information that I want, but it might not be as granular as you would want it. And at the top, it also tells you that it's recommended that you can use Manage Prometheus visualization.
And let me make a quick note here as Pierre is going to show you the dashboard. Prometheus and Grafana are two open source solutions that are part of the cloud native ecosystem that I mentioned before. As a monitoring solution, you know that there's an infrastructure needed to actually run the monitor solution itself, right? So you have the servers, the database, and everything needed to run System Center. You have the same for any kind of monitoring solution. What Pierre is going to talk about here is the fact that if you don't want to manage the infrastructure needed for Prometheus and Grafana, we have those offered as a managed service as well. And if you have an AKS cluster in Azure, of course, or on-premises, you can run AKS on-premises as well. You can leverage those options of manage Prometheus and Grafana to get data out of your cluster, whatever it is, on-premises or in the cloud, and bring it to the dashboard that Pierre is going to show now.
Yes, and that's a great point. Thank you for making it, Vinny. Everything we've talked about so far today applies to the cloud. And when I say the cloud, I mean Azure, because we don't control others. And you can do this locally in your own environment by using Azure Local or HCI with Arc-enabled HCI clusters.
Yep.
So you can run all of this for all your dev and testing and stuff could be done locally, so a lot cheaper. And then when you're ready to scale, put it up in the cloud.
Yep.
So we have all of our dashboards, and we've got all of the same information. We've got the CPU quotas, we have our memory, we've got memory request by namespace, which we don't get out of the box in Azure Monitor until we enable it and then start configuring what we're going to be collecting in terms of metrics and logs. Because when we're looking at onboarding different machines, so if I go back to my machines here, there is data collection rules, which are very much the same on the AKS side, where you're telling it what to configure. And that has a direct correlation of how big the bill is going to be at the end of the month. I have talked to companies that in the past, on-prem would collect all of their metrics, all of their performance counters, and all of the information they could possibly get into their local monitoring solution. Then they went to the cloud, and they kept that mentality. Well, if you're collecting all of that data, you have to store it somewhere. You're collecting it every second or every 5 seconds. You have to store it somewhere. At the end, you have to process it. When you process it and store it, it costs usage. You end up at the end of the month with a bill that your monitoring of your solution costs more than the solution.
Yep. Is that familiar to any of you? Yeah, and you learned from that, hopefully?
Yeah. So when we're looking at collecting data for our virtual machines and our AKS clusters and nodes, we have to figure out what the resources are. So which resource we want to collect from, because we don't want to collect from everything. Like, do we really care that the print server has got a 99% uptime versus a 98% uptime? As long as it's up and there's no alert that it went offline, then we're good. And the data sources, do we want the performance metrics? Do we want the disk information? All of that is performance counters, et cetera, et cetera. So we could do, right now, we're collecting the basics, but we could go custom and go very granular into what we're collecting. And that is the same for VMs and AKS, using Azure Monitor. Using Grafana and Prometheus is something completely different. If you've already, the nice thing with that is if you're already using a third party, something like open source Prometheus to collect your information on-prem, connecting your new AKS clusters becomes a breeze, because you have Prometheus that collects the data and stores it and processes, and then Grafana that just creates the dashboard and the visualization that you can give. How many people here are managers or decision makers? Okay. Sorry about that, but lots of managers really like those pretty pictures. So Grafana is one way of creating those nice graphs that you can put on the slide that makes them look good. So we have all that information, and that's why, I mean, if you collect all of that information for the 95 different pages that we have in terms of performance metrics, it's not something that I recommend, because just figure out and talk to your dev or solutions people and figure out what is important. And then as it grows, as you're operating it, adjust. This is not a set it and forget it. This is something that you have to look at every month and all the time. So our day 2 management or our day 2 DevOps are the same. So I'm going to turn that off, go back to my virtual machine. And in here, we have the same thing for Kubernetes, but we have it in the dashboard and the Prometheus to collect all of that data.
Yep. Do you mind if I show something real quick?
Absolutely.
So what Pierre was saying is, so all the data from your cluster and your application, it exposed to the Azure platform just like a VM, right? If you are using Prometheus and Grafana as a dashboard to see the Prometheus data, one of the things that you want to look into is the Prometheus rule group for what are the rules for collecting data, right? So what you see here are the default rules for collecting data from your cluster. The moment you enable monitoring for your cluster in AKS, and that data is being sent to Prometheus, you're gonna see rule groups, and you can create new ones for the things that your application does. So one of the things that you wanna partner with your developers, and I don't know why you pointed at me when you said developer, but is you wanna
You're the closest thing I know.
Is you want to know what are the things that have been instrumented inside of the code of the application so you know what's going on. So for example, if I go to my application and I say, for example, I want to generate another description for this product, you can see, or it should show, or you're going to have to believe me that this works. Am I looking at the right one?
Did you make your sacrifice to the demo gods this morning?
Yeah, let me just go back here. It wouldn't be a real demo if there wasn't no
one failure.
Yes. So I have my deployment that I showed before. I have the pod for that deployment. I can look for the logs. Select the pod. So it's streaming the logs from the pod. So I'm gonna say I'm gonna generate this one. I'm gonna add another one and move on if this doesn't work. I'm gonna add, hopefully this will bring something here. Yeah, you're just gonna have to believe me that this works.
Back to the deck.
Anyway, so you're instrumenting your code. So what happens inside of your app goes to the Prometheus database. So partner with your dev. That's the main thing.
So we've talked about monitoring and day two ops. I want to prevent any of that stuff to actually go badly before it even gets there. So for Azure, we have our Azure Policy, and now there are guardrails. And guardrails is not like something you go into Azure and you just like click the guardrail box. Guardrail is a concept of a policy that applies before you even do anything. So it prevents you from making bad decisions to start with. So in our case, we have our policies, and the policies are the same whether or not you're looking at VMs or Kubernetes. The scope is the subscription, the management group, the resource group, all of that stuff. The effects are the same: deny, audit, append, modify. The initiatives is just a bunch of policies that you configure together, so you deploy them as an initiative. Or compliance is continuous assessment and remediation. So when you're looking at a policy, most policies will be a warn. It will warn you that you're out of policy. But it's not going to do anything because it wants you to do it, or it wants you to document it, or it wants you to validate that that policy applies to it, but maybe that machine's got an exception. So now document it, put it in your policy, exclude it from the policy, apply it, or take it out of the scope. But the guardrail, as I mentioned, is just the policy that we are looking at. So if we're looking at our policies in Azure, right now I've got 0 compliant and 0 non-compliant because this is just an empty shell. I have not applied any policies to anybody, but I can go to my policy definition, and I've got all of the ones that are there. There's hundreds and hundreds of pages of that, but I want to fill my definition, and I want to search for Kubernetes. The first one that's there, which is kind of like a good thing for me, if I look at this one, do I have, no, I don't have Zoom it on this machine, my apologies. This is one of those guardrail policies. Guardrail policies are policies that are applied before you even do anything. So it doesn't wait for the system to be there before it warns or denies use of something. And in this one, it tells you that the container that you're using should not be using the latest tag. And the latest tag is basically the last image you have in your repo. Yep. Doesn't matter whether or not it's been validated, it's the last time it's been checked and merged and is the complete image. If you deploy this, you deploy the policy, you assign it to your resource group that has an AKS cluster in it, then the policy applies, and you go to deploy your new image for the Java storefront. Mm-hmm. If you have not put in a version number to your image, when you try to deploy it, we'll give you an error and will not allow you to deploy it. So that's what we talk about when we talk about guardrails.
And I think the point here is, if you're not familiar with best practices, Azure Policy and the multiple policies in there will help you figure out how to get started with best practices and then apply those.
Yes. Right. So there's a series of policies that help you with adhering to those best practices. Yep. Anyway, so we've looked at that. There is tons of different resources that you can have to learn how to manage your environment into your Kubernetes environment in your traditional. So right now I've got 2 pages, and I'm out of town. We're out of time, so you'll be able to download the deck from the Ignite website. And this is recorded, so that you'll be good. Kubernetes for the rest of us. Thank you so much for spending the morning with us. I hope this was valuable. First session on Friday.
I have one thing to say. Go to the next slide.
Yes.
Evals, please do the evals so we know that you like the content. Go to the next one, please, Pierre. I'm going to leave this here. This has nothing to do with the session. I want you to leave this room with an emotional connection to us, so your eval is bad. Thank you.